just so delighted to have a conversation with all of you because each of your companies is making such an important difference in the field of AI. And so let me start with a question about AI modeling that is related to scalability. We have seen great performance of scaling AI models, but we have also seen reports that that we're begin to see diminishing returns. And so what can we do to get over the hump? Have we hit a limit of what scalability gives us? And if so, what do you think is the right way to go over that? So maybe we can go across the entire panel. Jack, would you like to start us off?
Daniela, I think that when AI first burst onto the scene, of course, all of us in this panel know AI goes back now 60, 70 years. But in the recent revolution of the last 2 years, AI was one big blob. It was treated as one monolithic whole. Now I think it's time and it's appropriate to start differentiating different blocks of AI, different kinds of AI. I think in language AI, certainly people have gone to all the reaches of the internet and sucked in as many words and corpuses as possible and are hitting a bit of that wall in terms of the training set that you can use. And of course, you have to spend billions of dollars on that. In other areas of AI though, when we generate data, synthetic data that comes from equations or sensors or other kinds of sources, we are not even close to hitting any kind of data wall. So I think that we can scale very dramatically. And what we're finding quantitatively in the number side of AI is that we have 1,000, 3 orders of magnitude less compute in training the models than we have on the language side. So much more efficiency because of the pristine nature of the data that's generated from equations and because we don't have the hallucinatory effect of garbage data that comes in. So I think it's now time to start separating out, differentiating some of the different kinds of data sets, liquid nets that you have pioneered also showing much more efficiency. So I think it's time to now differentiate from just the transformer model to many other models that we'll start seeing in the AI family.
Thank you, Jack. Yossi, what's the Google perspective?
Yeah, to a question, we have this tendency to extrapolate, which of course is a big mistake, and we're in the business of doing research, which is essentially to find those around the corner kind of new ideas. So this notion of let's see where we're heading and what does it mean, that's never the right question. I mean, we could not anticipate where we are just a few years ago. Obviously, Transformer was a big breakthrough, and we've seen this growth now in the last few years. But in a way, we should remember we're really in the early days of this technology and this research. And now there are so many other ways that we need to keep on scaling and adding layers, thinking about the algorithmic approach to make the existing architecture more efficient, to find a way to optimize how we're actually using the current architectures, what other layers we're doing, how we're actually using additional complementary architectures. So in a way, I feel that we're really early on. It's, I think, pretty astounding what we already can get out of AI and the pace in which, and the models and the pace in which we can actually have progress. But I think we're really early days and we're going to see much more progress.
Matthias, you have spent your PhD days thinking deeply about this question. You're now the CTO of a company that is aiming to answer some of these questions. What's the liquid AI perspective?
Yeah, that's a good question. And one thing that's not just for liquid AI, but in general, I think, is that the scaling laws that Daniela and everybody is talking about, where you train a bigger model, and so on in a way, they're still alive. But one thing that has changed is that also the inference cost and the cost to actually operate these models, need to be taken into account. Because if you train such a huge model, running and operating these models, you cannot do that anymore competitively compared to like a smaller model that's much more efficient and much more like optimized on a certain task and so on. So I think we'll see, or you're already seeing like now much more in a way like other things in a way improving in a way the cost to operate and run and inference those models.
Peter, you recently sold your company to AMD and you're thinking deeply about how to get more out of the computation substrate. What's your perspective?
Yeah, I mean, we of course have a long experience in various types of use cases, and LLMs and Gen AI being, of course, the latest wave. I mean, I think a lot has been said, so I won't repeat that. I think scaling laws is obvious that it has a sort of, we need to sort of look beyond. We have innovations like liquid AI. We have new tokenizers. We announced yesterday a more efficient tokenizer. We will see more efficiency. We will see sort of improved performance. At the same time, I think we're still sort of mostly focusing on general purpose AI assistants and a very specific set of use cases, as was highlighted, and that's what I would double click on, is that we have a lot of new modalities that need to be tackled, and there's tremendous value in that. And that's where, you know, I am seeing and what I expect to see in the coming sort of years. Everything ranging from foundation models for tabular data to life sciences, biopharma, material sciences, say autonomous vehicles, robotics, and so forth. So I think we have a lot of value to be extracted still with new modalities.
Last but not least, Harrick, what's the Tata perspective?
So I think from Tata perspective, we are probably a lot closer to the users. So I think I would probably add a slightly different dimension of performance, which is actually, I would say, the value. So one is the tech perspective. How do you actually make tech better, cheaper, faster, which is, I think, my colleagues have actually articulated. From a value perspective, it's an interesting problem because we're very, very, very early stages of actually value realization and value scaling. Because we don't understand. In fact, we believe that future of any applications will actually be hybrid in terms of models. You will have wide variety of models that will have to actually get composed together because some will need explainability, some will need creativity, some needs adaptivity, and so on and so forth. And some, of course, needs better performance and scaling and so on. So I think the problem of actually engineering AI solutions that deliver value and how to scale value is actually a huge dimension of performance, if you will, which is probably going to make or break how this actually technology is starting to deliver substantial value to everyone.
I come back to you, Jack, because your company is very interested in a kind of a multidisciplinary approach, and so it actually dovetails very well with what Harrick says. Tell us a little bit about how you think about the multidisciplinary, the convergence of AI, quantum, and other computational tools to get to higher performance.
Well, Daniela, it is very interesting. In Sandbox AQ, the A is for AI, the Q is for quantum. Why bring these two things together? And the AI that we do, again, is on the quantitative side. It's AI that's trained on chemistry, engineering, biology, physics. Sorry, sir, everyone, shh. If we can just bring it down for the respect of the panel. If you have conversations, you can go outside. Shh, thank you. Okay, we can't hear ourselves. So with the integration of now quantitative AI, bringing together quantum equations, initially, Daniela, on GPUs. Today, we're doing the quantum equation work on the GPU, on NVIDIA and other GPUs, as well as then ultimately bringing in the QPU, the quantum processing unit, that is now coming. You saw the announcement from Google with the Willow chip. It's a good signal that error correction is working and will scale. That's very, very critical. And I think over the next number of years, we'll start to see the integration of CPU, GPU, QPU, in one hybrid mesh cloud. What we're seeing from a skills point of view, Daniela, is the need for what we call bilinguals. We need people trained in a domain like chemistry, but also AI, the same person. Not two different people, but actually the same person. I think when we talk about the future of what we need in this industry, it is not just AI engineers, not just AI PhDs. Many of us have those in our companies. We now have more than 85 bilingual PhDs in our company at Sandbox because we need folks who speak physics, chemistry, so on and so forth, and AI as well. I think this is a new category of work that is now emerging because of the need and the outcome.
You'll see Google has achieved such extraordinary feats with your AI solutions. So how are you thinking about the next steps? This panel is about the future of AI modeling. So are you thinking that transformers are the way, or are there other ideas that are bubbling up?
Yeah, so first it's important to realize, I mean, I'm sure people are hearing all the time that AI is going to impact all aspects of life. So let's double click on that for a moment. What does it actually mean? And again, quite often what grabbing the headlines are a few benchmarks or a few experiences. But let's consider for a moment all the different aspects in which we're using AI models. For example, let me give an example, the AI models that were adapted to be used in healthcare. Healthcare is one of the areas that AI can be transformative. So first remember, we should remember it's not only generative AI. We have many AI models that are already in production, already saving lives, already helping out with diagnostics, using various techniques, anything from image classification to embedding. Now with Gen AI, with generative AI, obviously there are new opportunities. For example, we looked into how can we adapt language models in order to be helpful in medical information, and for the first time show that it can pass the US medical exam in a passing score, which was a big deal less than a couple of years ago. But a few months later, we already showed that it passes it in 91%. And this is already being used by various healthcare providers to see how to actually integrate into a healthcare system to help healthcare workers, or using it for diagnostic conversation. There's early research showing that this can actually be extremely helpful. And again, this would be life-saving. So these are examples of how to use models for actually various applications. And inspired by that, we're looking into how to have models for education and learning. So these are the application domains. And of course, when you talk about life sciences, genomics, drug discovery, and so forth, for each of those, there are many opportunities to actually enhance, build on, add quantitative layers, add multimodal layers. For example, we can now use large language models that can take images and actually be able to say what's in the image, or use it in combination with other embedding models. So these are just a few examples. Now, if you think about other societal problems that we like to solve, in order to solve, for example, problems of helping predict floods, we have built a global hydrologic model, which are not large language model per se. So these are some of the examples that we need to keep in mind, the richness of where we are. But if we go back to what we typically discuss a lot, which are large language models, there are multiple aspects that require attention, perhaps. First, we all know that these models still have hallucinations. In some aspects, they are great for creativity, for scientific discovery, perhaps. In many other use cases, we need to do a better job in how to curb it. And we're making great progress on that. We actually have research showing how to have factuality, how to be able to provide better grounding, and even put out leaderboard with cold facts, so that we can actually help drive and encourage the industry to make progress on that. So this is another aspect. Or efficiency using algorithms, inference efficiency was mentioned. In fact, we found out that some algorithmic approaches, various algorithmic approaches, let me point out one called speculative decoding, can actually improve efficiency by a factor of 2. The interesting question is, how can we actually use algorithmic approaches to actually have order magnitude improvements on various aspects of language models? And the list goes on and on. So I think that the opportunities are there. Having said that, I think there's a lot of room for looking into new models, new architectures, some of which are presented at this panel, new approaches to build models, or how to use a combination of these models, because eventually we're talking about a very rich space of problems, and we'd like to solve that all. And in a way, we are in the first stage of let's show that we can solve something. And now the stage of optimization, I think, is going to take a fair amount of time. And I expect that us to see a lot of progress over the years.
That's really, really great. I'm very excited. I'm really excited about the Google approaches that combine the AI modeling with search, with planning. There is a lot of power in adding this layer of computation, as you said.
On that note, if I may, so for example, search is helpful in factuality, and one can actually test the output of generative models to see how it's supported not by search. But of course, search itself is now building on generative AI to provide overviews in a very powerful way. So hopefully we are going to see more progress on that, I'm sure.
Matthias, Liquid AI is achieving exceptional performance. How are you thinking about, how is Liquid AI thinking about transformers and beyond transformers?
Yeah, one thing, the way we build models, or we try to reinvent, or like, build our models, is like not think on a single dimension. For instance, like most companies looking at scale, just training bigger models, but in a way scale not just one dimension, but across all dimensions. For instance, data, like modalities, like not just using text, but also other data modalities, using synthetic data, other sources as well. Algorithmic aspects, using reinforcement learning, using teacher model, like with the distillation loss and so on, as well as architectural. That's what we originally started out of, like how can we, in a way, improve the architecture to make it more energy efficient, and so on. And another dimension that we're working on is like test time compute, as it was already mentioned, in a way, where you, in a way, like give the model more time to actually spend thinking about the problem. And it's really important that we don't just scale across one of those axes, but really like all, in a way, jointly. That's, I think, the way to succeed.
Peter, what's your point? What's your point of view?
Yeah, I mean, lots has been said already about transformers. I think just eventually value that you highlighted is what's important, and I think it's important to acknowledge that. I mean, yes, you need sort of compute platforms to be able to scale LLM training and eventually run efficient inference. And that's what we have been doing. We're one of the first companies that proved throughput scaling on AMD GPUs. But eventually, I mean, when these technologies become an embedded part of our everyday lives, they sit on our laptops, they sit on our devices, and that's what we have seen in the previous waves as well, as was highlighted by Yossi also on, there's other things than Gen AI. And so I believe now as well. So I really believe that there's a need for innovation so that you can run this on the edge in embedded environments, and that sort of requires a new perspective in many cases.
New ideas, absolutely. Harrick, I'm going to change gears now because we're only 6 minutes away to the end. So I want to talk with you about what your companies are doing to create products that yield actual revenues. And so maybe we can start with Tata.
So I think great question, actually. So I think in the previous panel or the discussion, there was a lot of discussion about actually augmenting people to actually become much better. And so we are actually spending a lot of our time and energy in trying to define what I would call as personalized AI, essentially a genius partner for every role, every person that understands the jobs that a person does and actually starts using this technology not only to improve productivity, but to dramatically improve the quality of decisions that person makes.
So is this a product? Are you already rolling it out?
We are in the process of building. So the intent would be to actually build a platform that will allow us to actually take almost any domain of work. I think some of the problems that we were talking about earlier, if it's actually drug discovery, for example, or even software engineering. Can we build a genius partner, if you will, or a personalized AI for an architect or for a cybersecurity expert or things of that sort? So that's really where we think, I think the opportunity is enormous. We are very, very early, I would say, at that stage.
Jack, what's Sandbox IQ doing?
We focus on the applications in biopharma, in chemistry. If you want to make a new drug, you want to create value. You want to create a new medicine for Alzheimer's, for Parkinson's, for cancer. This is on the value creation side. It's on the side of LQMs, large quantitative models. Language models, fundamental, essential to cutting costs, increasing productivity, code co-piloting, extending the productivity of people. But on the quantitative side, it's really about helping biotech companies, chemical companies. Just this morning, did an interview that we'll see just in a few hours about, can we take CO2 coming out of the energy industry and other industries and turn it into useful products? Instead of carbon capture and storage, CCS, can we say CCU, carbon capture and up value to a really useful product. That's an AI that we need that's trained on chemistry, not an AI trained on Reddit and cat pictures, right? So we need a different kind of AI to do that. But I can just put out one challenge also, Daniela, that I see as a need in this industry that we don't have a solution for, and I don't know if anyone has one, is how do we avoid the infinite loop of expansion compression, particularly with the rise of agentic AI? What I mean by that is that what you're now seeing is, Yossi and I want to give a talk. We have 2 and 3 bullet points we agree on. We put it into Gemini. It does a beautiful job making a wonderful speech, for us. And then you, the reader, say, you know what? I don't have time to read the whole speech and watch the whole 30-minute video. I'll have it summarized down to 2 points. The same 2 points that we started with. So we have like expansion, compression. Is there a way, particularly with agents who, they're somewhat smart, but they're also somewhat dumb because they're just doing their little job. How do we look at it from a total productivity perspective to avoid this expansion compression loop? I don't have a solution for that yet.
Well, good challenge for all of us. But what's Google doing for products?
Well, it feels like asking how to use AI for products is almost like asking how would you use computers or software for products. AI is a tool, a technology that empowers everything that we do. Obviously, it's already used by software engineers. It's actually making all the products more efficient. It's empowering whoever is using it, doctors, teachers. It's going to empower any industry. Obviously, our partners and customers in cloud are going to use and are using AI, and our products are actually becoming better and richer. And to Jack's point, check out NotebookLM, a way to actually become smarter just because you can actually consume 100 times faster more information. And by the way, get the incentive to actually look at the raw data when doing that from my personal experience. So I think in a way, we should remember this is an empowering thing. I'm very optimistic about how AI is actually going to empower individuals and humanity and actually make us all better and more productive. And of course, while taking care of all the other aspects that we did not discuss here of how to do it in a proper way, responsible way, and safe way.
And those aspects will be discussed throughout the day in other panels. But Yossi, coming back to you on the same question, there have been reports that talked about how generative AI is not producing the kind of revenues that had been anticipated. Do you see the same, or how does Google see these comments?
Really focusing on creating value, focusing on to see how to drive change. And again, as I mentioned, we are only getting started in journey, and we already see tremendous impact on everything that we do.
Matthias, Liquid is just starting, but I know there is a very strong focus on products. What's your opinion?
Yeah, I'm most excited about deep integration of generative AI into existing products in a way. Not just as a chatbot, as a help desk chatbot, but really deep integration into like existing software and existing products. I think that's really exciting.
So, Peter, 5 seconds. John just told me we're out of time.
I just like to re-emphasize the question because I very much like the fact that you're asking about revenue. I think AI is eventually just becoming an integrated part of products and driving revenue opportunity. That's how you should think when you're building. And then there's going to be a lot of takers that eventually get productivity and efficiency gains.
Thank you. Let's give it for this wonderful panel. Thank you for your insights.